Good morning, all. Phil Brown here, and welcome to another Taco Tuesday. As always, we're going to go ahead and jump in and program this part. But before I do, I got to say, if you guys want to see me do the rest of this part in the mill turn on Thursday, I want to go ahead and see if we can get over 100 likes in the next 48 hours. And if so, I'll release the mill turn version of this video. Seeing how my last turning Tuesday video did so, I don't think that's going to be a problem. So let's go ahead and jump into this. So as you can see, I'm going to switch from design to manufacture as always. We're going to create our setup. We're going to make sure that we're on the actual turning or mill turn. We're in our primary spindle, and now we are going to pick our Z-axis. In this case, I am going to work with my Z-axis in this direction. So we do have some kind of undercutting slash face grooving we're going to do here. But outside of everything, I'm pretty happy with all of this coming through. My stock size, again, I may actually extend my stock just a hair, or if I was to bar feed this, that might be something I want to do also, but we're going to offset from front, and we're going to give it, the typical 25 to 30 to face off. So from here, we could go through our pretty standard procedure of OD rough, facing. I'm just going to run down the line as I normally would. So let's go ahead and go to our library. We're going to go ahead and pick our, where is it here? CNMT right-handed tool. Always making sure we have multiple passes turned on. If you haven't caught some of my other videos, in the event that you guys actually had templates, you could have pasted your template in here, but we're going to run through this relatively quick. So again, I'm going to go with a 40 step down on roughing. We're going to go ahead and add a finishing pass. But before I do, if you guys, again, we got some undercutting stuff here that I'm not happy with. So let's get radial and axial grooving turned off. And then I'm also going to do a tangential extension here so that we can get that grooving tool in there after to part off this if we were bar feeding it. Now we're going to right click, we're going to go down, and we're going to do another derive operation straight into finishing. One thing I do have to do is allow a radial extension. What that does is it actually pulls it back at 90 degrees before doing your lead out, just hits that stock if there is any stock there and in the way. But at this point, if we go ahead and turn on our in-process stock, we're already have that face profile and the OD of this part finished. And if I was to simulate this real quick, I'm going to go ahead and get my stock so that it's not transparent. And very quickly, we're going to run through here. And as you're seeing, there's my OD rough and finish. Get my model out of my way. It almost looks like a piston. So let's go ahead and start to work on the front of this now. So what I'm going to do initially is get my part turned back on, of course. I'm going to go up here and I'm actually going to say, let's do a turning profile rough. And we're going to look at some of our options here and see which way we can go about this. So we do have the ability to do vertical passes. We also have the ability to do outside in, inside out, or both ways. So let's go ahead and say vertical passes, outside to inside, and we're going to allow both radial and axial grooving. And let's see what we get. So as you're seeing, we're stuck on the outside of our part. And the reason why we're stuck on the outside of our part with this tool path, again, I wasn't looking for much. I just want to get the path on the right area of my part long before we actually get everything going for true finish spec. But as you're seeing here is because we are saying outside profile, it's sticking to the outside of my part. So by switching to inside profiling and again hitting OK, what you notice here is we're starting to actually work inside that face. So even though this isn't really a bore, it's a face profile, it's going to treat your tool path as if it is a bore. So as you can see here, we are getting quite a bit of good things happening. And for demonstration purposes, let's go ahead and do a section analysis. And we're going to go ahead and grab half of this part. Oh, grab the wrong plane there. So we could always unselect, go back. And let's go ahead and hit OK. And then again, for demonstration purposes, I like to keep my stock off just so that we could really see what that tool path is doing. But as you're seeing here, we're coming in. And because of radial and axial grooving, this tool doesn't have enough relief to fully chase that profile. So first step would be is let's go to just a different tool and see what can happen, right? So we go back to our default library. We have a VNMT right-handed tool. It's got a ton more relief to it. And as you're seeing, we're still not getting fully in there. And that's, again, because that lead angle on that tool. Now, a lot of you may actually mount your tools in a different direction. And this is something that I would kind of recommend on a part like this, is if our tool, and what I'm going to do here is I'm actually going to go in and I'm going to edit our tool. Let's say this tool is actually facing 90 degrees, right? So again, with the simple regeneration, you're going to notice that we're now getting a lot more done, but we're also having some problems on the inside of our part, which we'll have to fix here. But as you're seeing, just by rotating that tool, we're now coming in and we're actually able to get everything on the face of this part to do this actual kind of profile or this recessed face. Again, maybe what I don't need is a right-handed tool. What I need is a left-handed tool. So what I'm going to do is I'm going to go back to my tool path. We're going to go ahead and open it up, and let's pick the left-handed tool. So again, we're just going to go back. We're going to go for that VNMT left-handed tool. Again, I'm going to leave it default, which is going to look a little funky here. It's not going to generate. And then again, we're going to go back and edit that tool. You could have did this while selecting. There's no problem with doing it before or after, but we're going to go ahead and kick it to 90 degrees. And as you can see, we're now faced 90 degrees. And again, with the regeneration, we're now doing that profile with a left-handed VNMT, and we mounted it horizontal in our machine. So again, this is a little different way to look at this and a little different way you could achieve something like this. You could also do this by all means. If we went in here and instead of doing it with a tool, I'm going to go in and I'm just going to pick, something like not a dog bone, but kind of like the lollipop tool, if you guys have ever seen me use this. So let's go ahead and see if we can, that's the lollipop. Again, I'm going to go back and hit select the second time so I can right click and edit this tool. But once again, we're going to point it towards the headstock. We're going to hit accept and we're going to select and then finish that up with an OK. And just as you guys are seeing, we're coming in and we're now using that lollipop cutter to rough out that profile on the face of our part. So if we were to simulate that, we could see what it's actually doing a little bit more in real time. I'm going to go ahead and just drag my mouse. Because this face here is much more recessed, we do have to get that material out of the way. So some of you may have been looking at that toolpath and kind of wondering what it was doing. It also thinks we are having a collision here, but that's just because my step down is a little too aggressive. But again, you can see how we can achieve that inside profile with nothing more than simple tools that you probably already have. There's no reason to go out and buy something complex. Just like we did before, I'm going to go ahead and right click. We're going to go in and derive, turning. We're going to do a finish pass now. Go ahead and hit OK. And now we have our finishing profile pass as well. So let's move to the outside. Let's do our actual grooving on our outside of our part that we're going to need to do for things like our piston rings and our oil groove. So again, we're going to go in this case, I'm actually going to do a turning single groove. And now I do know, because I've already measured this, that I'm going to have to set up a special tool for this. So we're going to go in and we're going to create our tool. This is going to be turning groove. The insert size itself is actually going to be 0.49 as per my model, or whatever your drawing actually calls out. I believe it's 0.49 if I'm actually thinking correctly. So we got to go ahead and update this as well. There will be no relief on this. So it's going to be basically as square as it can come. Pro tip here is you guys can actually zoom in and see this stuff now in real time, but you could also swing it around. And if you hold your shift key, depending on your settings, you could shift around to get to looking at it. We actually do not want a corner radius at all. So, well, it would be a minimum corner radius. So let's say we're going to go with like a 0.008. Again, making this kind of very trapezoidal with very little edge breaks. Again, I'm not going to spend a ton of time setting this kind of tool up. What we're really looking for is a very rough profile that we're going to use based on those locations. So now my geometry. Now this is where a lot of people get confused, and this is where my section analysis is really coming in handy. I am going to pick the back edge. And the reason why I pick the back edge is it's just something that I like to do because it's kind of a measured location. You can pick the front edge as well. You don't have to use the back, but we do have to tell it which side of the tool has to be on. So if I say it's on the back side of that edge, you're going to notice it shifted everything further back. Now, if I want to be in front of that point, again, that blue line that you're seeing here, guys, that represents the furthest back position of the tool. Now we're saying stay in front of that line. Again, super easy to set up. I may adjust a few things because we don't need to be stock OD here. We just need to be model OD. Again, I could change my clearance heights as well. There's a lot of things you could do with this to speed it up. But the key element is with those square pockets, we pick the lowest edge. We're going down to that lowest point to actually groove that out. And again, we could go in and we could simulate this. Oh, we don't want to look at our tools. We want to look at our simulation. And I'm just going to click and drag. No reason to hit play here. We're just going in. Nice and easy. Shifting over. Once again, nice and easy. So again, super valuable to be able to just do a single groove toolpath on a lot of this stuff. Now, here comes the part. Do I, in the case of this profile, do I now try to find a tool that is 0.149 wide to be able to groove this out? Or do I use a grooving path with that small tool and actually peck it out kind of thing and clean it up? Again, your guys' decision at the end of the day. It's really up to you. I'm going to go in and I'm just going to say, let's say we're doing, 5 of these. There's no reason to load up an extra tool. We're going to go a turning groove cycle. Again, I need to select my geometry. So what I can do is we could say rest machining. However, I'm going to cheat this a little bit. We're just going to select the front face here. And I'm going to select the back face here. And just like that, we can actually do our grooving cycle. So we do have our actual step over set here. We do have the ability to do roughing passes. Everything is kind of on by default. We could tweak that more if we have to. But really what I'm looking at doing is just going in, and as you're seeing this, it notches out the center, and then we come back and we clean everything up based on that. So again, here we go. We're coming in, and as you're seeing, it actually stepped over there, and it caused a little bit of a collision. Same here. We're coming all the way down and across. And the reason for that is because the amount of step over versus this tool is almost the same thickness, which is causing a lot of that dilemma. Another thing that's happening here is we do have inside of this toolpath, we have both up and down set. Now, if we go only down, this is going to make a pretty big difference, as well as if my step over was a little closer to maybe 20 versus 40. As you're going to see, we're now just plunging down each time. And again, this should stop our collisions. So we're going to go ahead and make sure stop on collisions on. And let's hit play this time. So as you're seeing, it's now notching that out. And we got no collisions because we were sliding back and forth. Again, if I wanted to do this with single grooving, you could easily go single groove, select your tool. Again, keep in mind, I picked the back edge. I'm going to go ahead and say I want my tool in front of that. And you're getting that grooving cycle with a single groove. Same rules apply here, guys. So we actually have a radius kind of space. So what I'm going to do is I'm going to inspect edge to edge again. So we're looking at an 065 kind of profile. Let's go back up and do a turning single groove. So we're going to pick that tool. We're going to go in and we're going to have to build this tool from scratch. Again, that's turning groove. Insert. This is actually going to be a 0.065 width. And then we're going to set our actual width here for the shank. And then from that, we're going to go ahead and set a custom corner radius. And that's going to be 0.065 divided by 2. And that automatically did the math. Now, you could reference groove width in a lot of different ways. It's not a big deal. But really all we're looking for is to get that circular profile perfect round. Again, we're going to go in and we're going to pick our groove position. We want to be in front. But one thing you'll notice is if we go ahead and leave this as is and simulate, let's go ahead and square up to this part, is as we come in, we're only going to go down to the deepest point of that edge that we picked, right? So we're not even actually going to go into our part. We're just barely touching our part and coming out. So we did absolutely nothing. So let's fix that. As always, we go back into our toolpath. We go to the menu that's going to adjust, which is our radii, which is going to adjust our X depths. And now we have a selected position. But again, we can now compensate that by negative 0.065. Again, we could do divide by 2. And what that is going to do is that's going to drop that profile down. And now if we simulate this all over again, we're going to go ahead and hit play. You can see we went perfectly in there and grooved out that nice undercut groove. So last and final thing we would have to do here is we go ahead and need to part this actual piston off, or in the event you're manually flipping it, I'm going to go ahead and just treat it as if we have a sub spindle to come in and grab. So let's go ahead and do a sub spindle grab. And we're going to come in, and where I'm going to grab is roughly, let's see here. Let's get a solid number. 2 inches in. That might actually be a little too close for comfort for the part off. So let's go 1 inch in. Plenty of material to grab onto. And I actually set that backwards, guys, if you were paying attention. So let's go back and fix this. So we actually want to wrap it to our stock front, but what we want to do is set our model grab position. And I'm going to set this from, stock front minus 1 inch. So even the best of us make mistakes just because we start getting click happy. It was very easy to go back and fix that, though. So now we're going to bring in our turning part off. So again, I'm going to go for a much beefier tool here. So if I did, in the case of this actual part, have that 149 part off tool in here, it'd be a perfect opportunity to probably use it for the full part off and doing the oil groove. But as you can see, we're coming in, we're coming down, and we're getting everything into position. Now, this is a trick if you're going to do a handoff, and this is something a lot of people miss. We're going to wrap it to this position, but the problem is when we wrap it to this position, our sub spindle is going to hit. So this is one of the very few times that I tend to recommend to people that you want to change your linking here. So we actually don't want to go to the safe Z position. We want to go to the first tool path point. And then when we retract, we want to stay at the last tool path point. So what's going to happen is our tool's now going to come down into this position, and then we're going to come in and grab. Again, super, super, super important. We'll go ahead and hit OK. And now let's do our sub spindle return. Again, not much we're going to hit here other than maybe unclamping the primary, or because we're running a bar, we're going to keep both clamped because we did separate this chunk off and we're pulling that back to the sub spindle. So little pro tip here for you guys is if you are planning on doing something of this nature, and let's go ahead and get that stock turned back on. You never want your stock model to be extended past where your part off is. And the reason for that is because when you're going to go in and do your sub spindle work and you're going to use continuous rest machining, you're going to have this big disc in the way that's going to cause a bunch of conflict. So what I'm going to do is I'm now going to go back to my setup and fix my overall stock length. So I think initially it set us at about 2.5, which gave me plenty and room to face that off. So now if we go down and we actually look at our tool paths here, we're going to have to regenerate everything because all of it's changed. So we'll give it a quick second here. Here's my part off cycle. And as you can see, we still have that very thin disc of material. Again, this is actually pretty important when we go to do our op2. So I'm going to adjust this one more time. We're going to bump that down to 2.4, giving us plenty to work with. One more time to regenerate. As always, let's go ahead and make sure that we're safe and everything's working well. So let's simulate with machine. We do have a couple of collisions here, and we can clean that up or evaluate whether or not those are actual collisions. Keep in mind, we did use that circle cutter on the front of our part. And as you're seeing, it's because we're starting too far back. We're also getting collisions as we get down inside of here with our retracts. Again, adjusting to a different tool or adjusting my tool path parameters would fix a lot of this. And we could actually, let's do that real quick. Since you guys are probably wanting to know how we would do that, we're going to go ahead and go to our turning profile rough right here. My passes, we do have vertical passes. We have the allow radial and axial cutting. Now, the real trick here is because we're doing this with a profile rough and we're doing vertical passes, it's not going to allow us to pick, do we want to go outside in or inside out? So now this can be a little tricky for a lot of you because you're going to realize like, oh, wait a minute, this is what's causing my problem. Now, if I constantly came from the outside in, we wouldn't have any issues. So how we could fix that is you could actually go back and we could do a turning groove. And now we're going to swap back to that disc cutter. And that should be this guy right here at 90 degrees. And now this is going to be considered an inside groove. We could go front to back, back to front. This isn't going to affect anything. But when we go to our passes tab, we do have up and down selection, which is also going to cause us the ability to edit what we kind of are doing. So as you're seeing here is I am getting an error. Let me go back again, is we need to just double verify. So let's say we're doing, well, we're technically doing face grooving. So let's go back to our turning tool paths. So there is no actual face grooving toolpath. And as you're seeing is we do have turning groove. However, it's thinking outside, inside, and not face grooving. So this is where a lot of people kind of get confused. So Again, using that grooving toolpath, we have that ability to set this up in a lot of different ways. So if we switch something from outside grooving, let's see what we get. So once we get back to outside, and I know this is confusing to everybody, and as you're seeing, I'm even having a trouble remembering it from time to time, that something as easy as switching outside to inside can get you to where you want to go. As you're seeing here, going outside to inside, it has dramatically changed where we're profiling. But on another path, we had to say inside to actually be inside the part. So here you can see we're doing our normal grooving path, and we're coming in and we're just plunging straight in horizontally on our Z-axis. Again, you have the ability to adjust some of this stuff based on your tool path. Again, we could say down only, up only, things of that nature to be able to adjust what's going on. Again, if we go back to that concept of us doing this with that actual roughing cycle, we can do very little when it comes to vertical versus horizontal. And again, you do have the front to back, back to front, but you can see as I change this, it almost does the exact same thing as grooving. So now there is a few other things you could do. You could just do something like this with a couple of passes. So if we say we want a couple of finishing passes as such, as you're going to see, we could just come around with those finishing passes. And because of the stock recognition, it's not going to extend outside of the stock. So again, this could be very beneficial if you're really looking to get some good cycle times out of a tool path. So let's say we wanted to do this with multiple finishing passes. So I'm going to bump that up to 5. We're going to go ahead and leave it as front to back. And we're going to let this thing go in. And as you're seeing, it is coming in and it's pecking out those different areas and cleaning them up as needed. We are starting a little further out than we need to. So this is where I tend to tell people, this is where we can kick on things like rest machining. The thing with rest machining is we're going to have a little bit of an error because we're roughing. So you're going to want to reorder. So again, we're going to reorder that profile finish. And now you can see that profile finish grooving path with multiple step overs is kind of making loops into our part. Again, this might just be quicker and easier than anything else that you're doing. You can also set this by all means, so you have front to back both ways also. That both ways, as you're going to see, is now going to kind of S-curve its way back and forth across your part. Again, getting this better and closer and more of a realistic profile to your part than anything else. So let's go ahead and simulate this and see if we have any collisions here. We are getting a couple of collisions. And again, this is something I know in Fusion, this tool is taking a little bit of a heavy bite by the safety parameters. However, I might be able to actually get away with this cut in real time. So we could delete our roughing now. A couple of different ways we played around with it. We've actually put it all into one very quick cycle as much as we could. Again, we're doing our single grooving here. So let's go ahead and simulate with machine. And grooving looks good. No collisions. I'm going to actually select my next couple of things. And let's just go ahead and run them all at once. So we're going to go ahead and hold control. Now, simulating the spindle grab, you may get an error where it won't do anything. That's more than okay, guys. If you do try to do a machine sim at a later date, and you're watching this video when machine sim is, if it is released, you're going to notice that spindle grab might cause you some errors. It's not a big deal. Using control allows you to pick all those tool paths individually. But one thing we didn't realize is that this tool is causing a collision on the part off. I'm not going to adjust this because what we're really working for here is to get us something to flip over our part. And as you can see, we did our sub spindle grab. So now there's no reason for me to face the backside of this part. And the reason for that is because these flats on our actual finished part are so tiny that it's going to make no actual difference on that situation. However, what I may want to do is if we're going to do some milling on the backside of this part, which we plan to, depending on the 100 views between now and Thursday, I am going to go ahead and I'm going to leave a little bit of material when we actually face off the backside of our part. So we're going to say model back. Again, I like to square up to my part, makes it just a little bit easier to understand my tool path. And I'm going to go past, maybe 20 thou. So first you got to click the window as I'm not doing and typing on my keyboard. We're going to give it 20. And if you notice, by giving it 20 positive, it brought it 20 positive in Z. So now we want to actually do this as a negative because we want to go negative 20 in Z. And we could go ahead and hit OK. And just like that, we've actually cleaned up that back profile for creating that actual part off cycle. And again, you can see how easy it is to actually come in and do outside grooving, as well as kind of a very shallow profile in the front. I know we've done it a lot of different ways, and you guys can take your opinion, and by all means, give me your opinion down in the comments. And before I go, I have to say it, don't forget to like, follow, and subscribe if you want to get the latest notifications of content like this. Or if you're just enjoying this content, that's always great to help me. And any feedback you have is always taken and put into place as soon as possible. Now, before we get the rest of the day going, I do have to say, it's not what you know, it's who you know. And if you guys don't know something, by all means, reach out to us at JitCAD-CAM, as we are here to help you in any field or any questions you have. Support link is down below to go ahead and put in those tickets where we can get to you as soon as we can. Thanks. Have a great rest of your day.